Hello, and welcome back to more pre-calculus. We are now getting into section 1.8, which is combinations of functions. Composite functions being the main one we're going to be looking at. But before we get into that, we're going to first start off with some easy stuff. So we're going to look at the arithmetic combination of functions, so our sum, difference, product, and quotient functions. Now, the biggest thing to keep in mind with these is that we're just looking at how the notation impacts what you're actually doing. So we can see that the notation for sum, we just have f plus g in parentheses, and then we have our x on the outside of that. Now, by definition, this means this. So this is really the same thing as saying f of g or f of x plus f of g. Very similar formats for the subtraction. So we have f of x minus g of x, f times g of x, f of x times g of x, and so on. And then, of course, the big thing about quotients, we can't have the denominator equal to 0, so that function cannot be the 0 function. Pretty straightforward. So now let's try a few examples just to make sure we got it down. So if we have a function f equal to x squared plus 1 and g of x equal to x minus 4, and we want to know what f of g of 3 is, what do? Well, the first thing we should do is use the definition and rewrite it in the more user-friendly form. So we would say f of 3 plus g of 3. And so now from here, we can use our actual functions and substitute those values in. So let's see what we get. So a 3 squared plus 1 plus, and now I like to use parentheses around a second function. The first function, you don't really need them around it. You could put them in if you wanted to, but you don't really need them on the first one. The second one, I would err on putting them in there. So 3 minus 4. And now we just simplify. So we got our 9 plus 1 is 10, plus a negative 1. So we should end up with 9. All right, let's try the next one. So now we have our subtraction, our difference function. And so now we want to plug in 2t. So again, let's start off with the definition. So f of 2t minus g of 2t. And now we can substitute. So 2t is replacing x in our function. So let's use parentheses around that. And add our 1. So there's f of 2t. And now, again, let's use parentheses around the second one. So we want to substitute a 2t in for x in our function here. So we don't really need parentheses around it because that's the only thing in the front. And then we can close our parentheses after that. All right. Let's get rid of our parentheses. So 2t squared better become 4t squared plus 1. Let's distribute our minus sign. So minus 2t plus 4. And now let's combine any terms, which we can do a little bit. And we'll put it in a nice descending exponent form. So 4t squared minus 2t plus 5. All right, so again, just being really careful and deliberate with those parentheses is going to be beneficial when you're doing these types of combinations and combining different functions. So, all right, last one here. We have two new functions for f and g. So we have f of x is x squared plus 5, g of x square root of 1 minus x. Find f over g of x and find its domain. All right, so we know that f over g of x is equal to f of x over g of x. So we can just plug and chug, although there's not much to chug here. So there's our division, our quotient function. Excuse me. Now the big question, what is the domain? Now we can analyze this a couple of ways, but the big thing is we have a fraction. And fractions are notorious for being an issue when the bottom is equal to 0. So that's one thing we want to check here. The other thing too would be to check the top. Is there any issues with x squared plus 5? Is there any number that would cause a problem in there? And hopefully you're saying the answer is no. There is no problem with the top. It's just the bottom that's going to be an issue. The other thing we want to be careful about is that we can't have negatives under the square root. So we can't have it equal to 0 and we can't have it be negative. So let's first find out where it's equal to 0. So if we set that equal to 0, well, the first thing we would do to solve this would be to get rid of that square root. So if we square both sides, it doesn't really change the other side. So now we can quickly solve this. So x is equal to 1. So 1 is where things start to pivot and start to change. So we know at 1 we get it equal to 0, so we can't have that. But now the question is do we want numbers to the left of 1 or to the right of 1? So let's just try a couple of examples. Let's try 0. If we plug in 0, that's on the left side of 1. 1 minus 0 is 1. Square root of 1 is 1. That's okay. So it looks like numbers that are smaller than 1 should be okay. Let's check the other side though. If we checked x equal to 2, now we got 1 minus 2 is negative 1. Now we got problems. So the left side of 1 is okay, the right side is not. So our domain should be from negative infinity to 1, and we don't want to include it, so we want to use a parenthesis. So that should be our domain. All right. Now, let's take a look at the first example of the next and more important type of combination, which would be the composition of two functions. So when we compose two functions together, we're going to be using this symbol here, which is a raised open dot. So f of g of x. That's the way you would actually say that. So f of g of x. And so we can also write it in this format too. So this format means this format. And this we can work with a little bit easier. So let's just do a couple of examples here. So we want to compose them both ways. So f composed with g and g composed with f. And we got our two different functions. Now the one question you might say is, well, shouldn't they be the same? Does it really matter which way I compose them? The answer is yes, it does matter. So you might get something different, and a lot of the times you will. So let's just see what happens here. So if we have f of g of x, we know by definition that that is f of g of x. And now, how do we break this down? Well, anytime we have parentheses, where do we usually start? If we have batched parentheses, we should start in the innermost set and then gradually work your way out. So the only thing we should do first step is just replace this g of x with what it's equal to. So we got f of x minus 1 to start. Now we can work with function f. So this x minus 1 is our input, and we want to replace x in the function. So this should be equal to x minus 1 squared. And if we wanted to go a little bit further with that, we could. If we wanted to FOIL that out, you could easily do that. So x squared minus 2x plus 1, same thing. So either one of those answers would be acceptable. Let's see what happens going the other direction. So when we have g composed with f, then we want the g on the outside and f of x is on the inside. So now we start off by replacing f of x with x squared. So we want g of x squared. And so now what's that equal to? Now we need to replace x in our function with x squared. So we get x squared minus 1. And that's it. And we can see that these are not equal to each other. So how we order that composition is going to be important. It does make a difference. We will see some instances where they come out to be the same, but most of the time they should not. So, and that's the concluding statement here. So we see that f of g is not equal to g of f, and in most cases this is true, but not always. So let's stop here, and we'll see some more examples of compositions in the next video. Stay tuned.